Okay, in this video, we're going to answer fill-in-the-blank questions from all of Chapter 3. Chapter 3 was on polynomial and rational functions. Also, the last section of Chapter 3 included variation. So directly proportional to, inversely proportional to, jointly proportional to. What I've done is I've taken every single fill-in-the-blank question from all the sections. There's total about 50, and just kind of like threw them into a hat, mixed them up, and picked them out randomly. So the subject of each of these, the topic, is completely random. Now, why are we doing this? Didn't we already go through these sections and work example problems? Well, this is just a matter of retaining the knowledge. This is going to help to cement all of this into your head after you've gone through the textbook, read through the textbook, watched those videos, worked example problems. Now you can come here and answer these fill-in-the-blank questions. It'll really help to bring everything together. Okay. The amount of a person's paycheck varies what as the number of hours worked? So this is a variation question. Does it vary directly or inversely, or maybe jointly? Well, okay, as the number of hours worked goes up, the paycheck, the dollar amount of the paycheck also goes up. So it's a direct variation. Varies directly. If k is a non-zero constant real number, then the statement y is equal to k over x implies that y varies, and this is just a coincidence that these two happen to be the same topic, that y varies what as x? It varies inversely. Right? You have direct variation, inverse variation, and joint variation. But joint variations, it's kind of just the same thing. You could word a joint variation as a direct variation. So it's really the main ones are direct and inverse variation. A function defined by f of x is equal to a sub n times x to the n plus a sub n minus 1 times x to the n minus 1 plus a sub n minus 2 times x to the n minus 2, following this pattern all the way down to a sub 1 times x plus a sub 0, where all of the coefficients are real numbers and the leading coefficient is not equal to 0. What is this? Well, that's the classic definition of a polynomial function. Right? You have all the coefficients are real. That's not a requirement for a general polynomial, but the ones we work with, that's the case. The coefficients are real. They're not functions of x. None of the coefficients are functions of x. But the x terms are all raised to, let's see, does it say, it should specify, these n's are integers. So that's the characteristic of a polynomial. It's all constant coefficients multiplying the variable to a positive integer power or 0. Like some sum or combination of those types of terms, that's a polynomial. Right? If every single term, you can have a monomial, one-term polynomial, but in general, if you have a sum of terms, if every single term contains a constant coefficient, it could be non-real, but we usually think about it as terms of real coefficients, multiplying an x to a positive integer power or 0, then that's a polynomial. The blank of a polynomial, f of x, are the solutions or roots of the equation f of x is equal to 0. This is the zeros, right? The zeros of a polynomial, which you can think about it in terms of, yes, solving f of x is equal to 0, but even if you just have a polynomial expression sitting there with no equation, you can still think about the zeros of the polynomial. It's the x values that you plug in and it makes the expression 0. We call those zeros, or also they're known as roots. You can call them roots. I want to say zeros are, any function, even if it's not a polynomial, has zeros. But roots is more something it's a term used for the zeros of a polynomial. Don't quote me on that. I'm not sure if that's an official, I'm not a mathematician, but I think that's the way it works. You can use the term zeros for any expression, no matter what it is, polynomial or not. But a lot of times, instead of saying zeros for a polynomial, you'll say roots. But like if you had a rational function, then you don't say roots, you just say zeros. I think that's the case. That's how it works. But don't quote me on that. The domain of a rational function defined by f of x equal to p of x over q of x is all real numbers excluding the zeros of the denominator. The denominator polynomial. It's a rational function, a ratio of polynomials. The roots are the zeros of the q of x. You can't put that. That's not a valid input. That's outside the domain. But everything else is within the domain because polynomials have domain all real numbers. Given this rational expression is equal to this, use the division algorithm to check the result. Okay, the division algorithm. So the division algorithm, well, I don't know how much of a fill in the blank this is, but let's bring this off to the side, or to a blank sheet to get some room. Okay, the division algorithm. You shouldn't have to memorize the division algorithm because it comes straight from you use the same terms as you use in regular long division. So if we had 100 divided by 7, okay, so we write that as this, 100 divided by 7. Okay, we know that this is the dividend and this is the divisor. It's the same with polynomials. So it's with the division algorithm, you do d of x for dividend. Or no, I'm sorry, that's wrong. Because dividend and divisor have the same letter. So for the dividend, they just call that the p of x or f of x. They just give that that's the main function, and then the dividend gets the letter d. Okay, that's equal to what? Well, so if we do the division here, you've got 7 times 4. Okay, we know that this is equal to, it's the quotient, and then we would put 2/7, but another way to look at this is you do 14 plus, and then you do the remainder over the divisor, right? So let's write that out. The function divided by the divisor is equal to the quotient, and with polynomials, they're all functions of x in general, okay? Plus, and then the remainder gets an r, and then the divisor, once again, is the d, okay? So is this the division algorithm? No, but it's close because the division algorithm is going to have just one of each of these. So we have 2 divisors. How do we only have one divisor? We do this. Multiply this entire equation by d of x, and that gives the division algorithm. Or q of x, d of x, plus r of x. There's the division algorithm. So now they want us to use this algorithm to check the result. So here's f of x, the divisor. So 2x cubed minus 5x squared minus 6x plus 1 is equal to the quotient. There's the quotient, 2x squared plus x minus 3 times the divisor plus the remainder. You see? So this is what we need to, let's expand this out. So 2x cubed minus 6x squared plus, let's see, it'd be x squared minus 3x minus 3x minus 9 minus 8. Is that right? 2x cubed minus 6x squared plus x squared minus 3x plus 9. Okay, so we're left with 2x cubed minus 5x squared minus 6x plus 1. There you go. If c is a real zero of a polynomial function and the multiplicity is 6, does the graph of the function cross the x-axis or touch the x-axis without crossing at the point c0? Well, it's an even multiplicity. It's going to touch. If the multiplicity is even, it bounces off the graph. If it's odd, it crosses it, the x-axis. It bounces off the x-axis or crosses the x-axis. Let f of x be a polynomial, an inequality of the form f of x is less than 0, f of x is, so if f of x is a polynomial, any inequality, and then the other side is equal to, is a 0, is called it's a polynomial inequality. If you can put it into that form. So it's not, you might say, well, why does the one side have to be equal to 0? Because you couldn't have, like, if you had f of x is greater than or equal to the square root of x. Well, f of x is a polynomial, but that's not a polynomial inequality. They're saying you take all the terms and you put them on one side, and the other side is 0. Whatever, if f of x is a polynomial, then it's a polynomial inequality. And this is going to be the definition of any type of inequality. If you bring all the terms on one side and you simplify and you have a rational expression, a pure rational expression, well, then it's a rational inequality. Same, right? If the polynomial is of degree what, then the inequality is also called a quadratic inequality of degree 2. It's just like a quadratic equation. If you take any quadratic equation and change the equality to an inequality, you have a quadratic inequality. If y varies directly as 2 or more other variables, such as x and w, then y is equal to k times x times w, and we see that y varies jointly as x and w. Given the function defined by this here, the value 0 is a 0 with multiplicity 5. That's if you plug in 0, h of 0 is equal to 0. That's a 0 of the polynomial. Is this a polynomial? I think it is. Yeah. But it has it's to the 5th power though, so its multiplicity is 5. And the value minus 0.6 is a 0 with multiplicity. Yeah, if you plug in x is equal to minus 0.6, this also makes the function equal to 0. Okay, and that 0 has a multiplicity 3. If f of x is a polynomial of degree n is greater than or equal to 1 with complex coefficients, then f of x has exactly how many complex zeros, provided that each 0 is counted by its multiplicity. It has exactly n. That's the fundamental theorem of algebra. Okay, now what does this mean? Complex coefficients? Well, they're just saying, they're giving the most general definition of a polynomial. You could have complex coefficients. You could have x. You could input an x that's imaginary or complex. Okay, and it has how many complex zeros. When they say complex, it's not saying it has n imaginary zeros. Complex includes real numbers. That includes 5 plus 0i. They're calling that a complex 0. So any polynomial, no matter what it is, right? You have complex. It says complex coefficients. Well, a polynomial that has all real coefficients, that's still complex coefficients with imaginary part 0. So any polynomial, no matter what it is going to have exactly n zeros if you include imaginary zeros. The solution set for the inequality here is what, whereas the solution set for this inequality is what? So this, I'm assuming they're talking about a special case here. Yeah, this, if you just look at this visually, this, no matter what x you plug in, is going to be greater than or equal to 0. So there is no solution here. Whereas the solution set for this is, it's all real numbers. The solution set is all real numbers here because this is always going to be greater than or equal to -4 for every x. Here, this is never going to be less than -4, right? If k is a non-zero constant real number, then the statement y is equal to k times x implies that y varies directly as x. A quadratic function is a polynomial of degree 2, right? Quadratic. It's like a quadratic equation, degree 2. But they're talking about a function. If the graph of a polynomial function has 3 turning points, what is the minimum degree of the function? Well, we know that if we take the degree and subtract 1, that's the maximum number of turning points a polynomial function is going to have on the graph. Now, this is not talking about bouncing off the graph. They're not considering that a turning point. They're talking about, like, that would be a turning point. That would be a turning point. That would be a turning point. So the maximum number of turning points is n minus 1. So if a polynomial function has 3 turning points, then this can't be less than a degree 4 polynomial, because if it was degree 3, it would have more than n minus 1 turning points. So the maximum degree of the function is 4. If c is a real zero of a polynomial function and the multiplicity is 3, does the graph of the function cross the x-axis or touch the x-axis at c0? Well, it's going to cross, right? Odd multiplicity. A linear function is a polynomial of degree 1, right? A linear equation is like it involves a polynomial of degree 1, a quadratic equation polynomial of degree 2. Same with functions. The notation, this x arrow to infinity here, is read as x approaches infinity. Let f of x be a rational expression, an inequality of the form. So yeah, that's a rational inequality. If you take any, the idea is if you take any of the equations we studied, radical, rational, in chapter 1, any of those equations, and you just replace the equation with an inequality, then you have that equation as an inequality. And the way you look at it is, if you bring everything to one side and have all terms on one side and 0 on the other side, and you simplify and you have the f of x is a distinct type of expression, like a rational expression, a polynomial of degree whatever, etc., radical, then that's called it's that kind of inequality. The value of k in the variation models y is equal to kx and y is equal to k over x is called the constant of variation. Even for the joint variation, it's still the constant of variation. Like if you had k, y is equal to k, w, x, it's the constant of variation. A real number a is called a lower bound of the real zeros of a polynomial f of x if all real zeros of f of x are what are equal to a. Yeah, greater than or equal to. It's a lower bound. Right? We talked about the upper and lower bounds. Given f of x is equal to this here, the vertex of the parabola, so this is the vertex form of a parabola or a quadratic equation. The vertex of the parabola is what point? Well, we know it's h, comma, k. Okay? Given this equation here, if a is greater than 0, the parabola opens upward. And the what value is, so yeah, if it opens upward, it's not going to have a maximum, but it's going to have a minimum value, which is going to be at the vertex, right? The y-coordinate of the vertex. Given a polynomial f of x, the factor theorem indicates that if f of c is equal to 0, then x minus c, it's a factor. Right? That's the factor theorem. If you can plug in to like a polynomial expression, a value of x that makes the polynomial exactly equal 0, then you can take what you plugged in, put it into an x minus c expression, and that's going to be a factor of the polynomial. Okay, furthermore, if x minus c is a factor of f of x, then f of c is equal to 0. That's the factor theorem. Consider a rational function in which the degree of the numerator is n and the degree of the denominator is m. If n is what m, then the x-axis is the horizontal asymptote. So yeah, the numerator, if n is less than m. If n is greater than m, then the function has no horizontal asymptote. Right. If n is equal to m, then there is a horizontal asymptote, but it's equal to something else, not 0. The graph of f of x is equal, so that there's the vertex form of a parabola, is a parabola, and the axis of symmetry is the line given by x is equal to the coordinate of the vertex, the x-coordinate of the vertex. A real number b is called a what bound of the real zeros of the polynomial f of x if all the real zeros of f of x are less than or equal to b. It's an upper bound. The notation shown here is read as, so x approaches 5 from the negative direction or from the left? Given the division algorithm, identify the polynomials representing the dividend, divisor, quotient, and remainder. Okay, the dividend is like they just give that the f of x, like the general function letter, but the other letters are going to go by the first letter of the name. So this is the divisor, this is the quotient, this is the remainder. Okay, here's a separate question. Given y is equal to 2x, evaluate y for the given values of x. So, okay, let's see. You have x, 1, 2, 3, 4, 5. Okay, y, so if y is equal to 2x, okay, how does y change when x is doubled? How does y change when x is tripled? Okay, well, yeah, y is also doubled. If you double, it's like you're multiplying both sides of the equation by 2. Y doubles. Here, y triples. Complete the statement. Given y is equal to 2x, when x increases, y increases proportionally. Now, you might say, well, what if you had something like y is equal to 2x squared? So now if you double x, you quadruple y. Because it's like y is equal to, it would be, let's see, 2 and then 2x squared, right? So you're left with 4x. You're left with 4x squared. Well, but then that wouldn't be, you wouldn't say that x and y are proportional here. What you would say is that, or directly proportional, sorry, that you wouldn't say they're directly proportional. What you say is that y is directly proportional to x squared. If you double x squared, you double y. Okay, complete the statement. Given y is equal to 2x, when x decreases, y decreases proportionally. Explain why the number 7 cannot be a rational zero of this polynomial. Well, okay, we want to look at the rational zero theorem. So P over Q, okay, the factors of the 6, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, and then the factors of the leading coefficient, plus or minus 1, plus or minus 2. So, yeah, there's no 7 in here. So 7 cannot be a rational zero. These are all the possible rational zeros, all the combinations of this. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, those integers. Plus or minus 1/2, plus or minus 3/2, plus or minus, well, 6/2, that's just 3. And then, yeah, that should be it. Yeah. The conjugate zeros theorem states that if f of x is a polynomial with real coefficients, and if a plus bi is a zero of f of x, then what is also a zero of f of x? Yeah, the conjugate zeros theorem. If you have a polynomial with real coefficients, which is the ones we deal with most of the time, then if you know that a plus bi, this complex number, is a zero of f of x, then you also know for sure that a minus bi is going to be a zero of f of x. The vertical line drawn through the vertex of a quadratic function is called it's the axis of symmetry, the parabola, drawn through the vertex. Answer true or false. If x plus 3 is a factor of a polynomial, then 3 is a zero of the polynomial. False. Minus 3 is a zero, right? If it's a factor, then the idea is you set this equal to 0, you solve for x, you get minus 3. The function given by f of x is equal to this here. Is this a polynomial function? Yes. You can write this as minus 3x to the 5th plus 1/2 plus root 2. Like, we could write it this way. F of x is equal to minus 3x to the 5th plus root 2 plus 1/2 x. right? That's a polynomial. The root, they're trying to confuse us with the square root. That's just a part of the coefficient. The coefficients can be any real number in a polynomial, any real number, even irrational. To locate the vertical asymptotes of a function, determine the real numbers x where the denominator is 0, but the numerator is not 0. Right? For a rational function, when you think about vertical asymptotes, that's where you're dividing by 0, but also you're not also dividing by 0 in the numerator. Or no, the numerator is not equal to 0, because the vertical asymptote, the function is ballooning to positive or negative infinity. So as long as you have some non-zero number in the numerator and you're getting very close to 0 in the denominator, then and then you have something non-zero in the numerator, you're getting very close to 0 in the denominator, you're going to balloon to infinity. If both are going to 0 in the numerator and denominator, then that's like a hole in the graph. It's a different scenario. Given the function defined by this function here, this looks like a factored polynomial. The value 1 is a 0 with multiplicity 3. And the value minus 5 is a 0 with multiplicity 4. Right? Those are two zeros, and there's the multiplicities. A function defined by this here is called a what function? Okay, that's a quadratic function. Polynomial of degree 2. Polynomial function of degree 2 is called a quadratic function. What is the maximum number of turning points in this graph here? Well, it's going to be n minus 1, 5. That's the max. Not necessarily, doesn't mean this is going to have 5 turning points, but the max is 5. The remainder theorem indicates that if a polynomial, f of x, is divided by x minus c, the remainder is f of c. The solutions to an inequality, f of x is less than 0, are the values of x on the intervals where f of x is what? Where it's negative, right? That's the whole idea with these inequalities. You set one side 0 and the other side the function, and so now it's a problem of finding where the function is, the intervals where the function is positive or negative, which means greater than or less than 0. The function given by this, is this a polynomial function? No. Because you've got x to the 1/2, x to the minus 1. That's the main characteristic of a polynomial function is x. The x's are going to be always raised to a positive integer power or 0. The line x is equal to c is a what asymptote of the graph of the function f if f of x approaches infinity or negative infinity as x approaches what from either the left or the right. Okay, this is going to be if you're approaching to approach a vertical line going to infinity or negative infinity, if the idea that you're approaching a vertical line means you're approaching a x value, a constant x value, right? X is equal to c is a vertical line. Okay, and so if it's approaching, the function's approaching infinity or negative infinity as it approaches that x equal to c, as it approaches x equal to c from the left or the right, either or, then it's a vertical asymptote. Given y is equal to 24 over x, evaluate y for the given values of x. Okay, so we'll do this process again. So 1, 2, 3, 4, 6. So you got 24, 12, 8, 6, 4. Okay, so I'm not sure what when x is tripled. Yeah, I mean, okay, we can see when x is doubled, y is cut in half. When x is tripled, y is divided by 3. When x is quadrupled, y is divided by 4. And that's the idea. That's what, when x is doubled, y is halved. When x is tripled, y is cut by 3. So that means that when x increases, y decreases proportionally. When x decreases, y increases proportionally. That's the meaning of inversely proportional. Now again, if you had y is equal to 24 over x squared, then you would say y is inversely proportional to x squared, as x squared is doubled, then y would be cut in half, etc. The volume of a right cylinder cone varies what as the square of the radius of the cylinder and as the height of the cylinder? Okay, a right circular cone. Okay, V is pi r squared times h over 3. So the volume of the right circular cone varies what as the square of the radius of the cylinder and as the height of the cylinder varies directly. Exactly. Varies directly. Suppose that f is a polynomial function and that a is less than b. If f of a and f of b have opposite signs, then what conclusion can be drawn from the intermediate value theorem? Okay, well, that means that there's a 0 between a and b. Somewhere between a and b, there's a 0 of the polynomial. Given f of x is equal to, here's the vertex formula, the vertex form of a quadratic equation. If a is less than 0, the parabola opens downward. And the maximum is at that the y coordinate of the vertex. Answer true or false. If root 5 is a 0 of a polynomial, then x minus root 5 is a factor of the polynomial. True. Because you set this equal to 0, solve for x, you get root 5. The values of x in the domain of a polynomial function, f for which f of x is equal to 0, are called the what of the function? The zeros or the roots. We'll say roots. The time required to drive from Atlanta, Georgia to Nashville, Tennessee varies what as the average speed at which the vehicle travels? Inversely. So as the speed increases, the time required to drive decreases, right? And they say proportional because they're just talking about distance is equal to rate times time. You know, if you look at this from a simple, very simple standpoint of distance is equal to rate times time, the average rate, yeah, you could do that. If you were making this drive, you could, you know, yeah, you're stopping and going, etc., speeding up, slowing down, but the average rate times the time is the distance traveled. A student's grade in a test varies what as the number of hours the student spends studying for the test. You know, this is not a scientific relation here, but you can think about it. You could say it's going to be, in general, it's going to be, varies directly. The more hours he studies, the higher the grade's going to be. The less hours he studies, the lower the grade's going to be. Again, that's not a, and you would say, okay, the grade is k times the number of hours. That would be a way you could, that's a, if you want to give a rough description, you can think about it this way. That's not an official math formula. You study for 10 hours, you get a B. You study for 20 hours, you get an A. Well, no, but you could think about it that way, though. If you could come up with a formula that was accurate, then everything else being held constant, I bet you it would be, you'd see like a proportional relation or a directly proportional relationship.